We're going to get started going through the review together. Please fast forward to the questions that you have. For number 1, they want us to find the 12th term. So our N stands for terms. So we're going to plug in, for this first one, a 12 in for our N's. Now if I was going to type this into my calculator, I'm not going to put parentheses. I'm going to type it exactly how I have it written. So I would do negative 12 to the second power, and then plus 40, and I should get negative 104. If I'm doing it by hand, I'm doing 12 squared first, getting 144, and then taking it times the negative 1, so negative 144 plus 40. Number 2, they want to find the 18th term, so we're going to plug 18 in for our N's. For this one, if I'm putting it into my calculator, I do want to put parentheses on this one, because this one already has parentheses. And then I get negative 2. Alrighty, for this next one, number 3, I want you to change it. There is not a recursive formula for the original problem that I gave you. There's an explicit one, but not a recursive. So I want you to go ahead and change it. And then from here, recursive, you're relating it from the previous term. So if we go over here off to the side and we make a table for it, we want to be looking for the pattern this way, relating it from the previous term. If we can't find a pattern this way, we want to be looking at the diagonals. Now notice each time they keep adding 2, so we're going to write that as a to the n equals a to the n minus 1 plus 2. This a to the n minus 1 simply means the previous term. And we're always going to have that a to the n minus 1 in a recursive formula. So that is our final answer. Now this next one, we're going to go ahead and make a table for it. Alrighty, for this one, we're looking for the pattern going downwards. Notice they're dividing by negative 2 each time, so we can write that as the previous term divided by negative 2, or you can just write it as a to the n minus 1 divided by negative 2. So either is perfectly fine. Now this next one, it wants us to find the explicit formula. So to find the explicit formula, instead of relating it to the previous term or using the diagonals, we need to be relating it to the term number itself. So again, I would still recommend making the table for it. We're looking for that pattern left to right. Now for this one, as I was writing it down though, one thing I did notice up and down, it was adding 5. So even though we're supposed to be relating it left to right, if you see that up and down it is adding or subtracting by the same number, think of our explicit formula in slope-intercept form, that number that we're adding or subtracting by is going to be that number, that slope, the number in front of your n. And then we just have to figure out our y-intercept. So if I plug in one of these numbers, let's see if this works. So if I plug in 1, 5 times 1 is 5. It's supposed to equal 6, so I would have to add 1 to it. Now let's try another one, and it should work every single time now. So if I plug in 6, 5 times 6 is 30, plus 1 is 31. So it's working every single time. So then that is my equation. And then they have a follow-up question, find the 20th term. So I'm going to plug in 20 for my n's and find what that 20th term is going to be. So I would have 100 plus the 1, or 101. Alrighty, now this next one, I want to find an explicit formula for it. Now for this one, notice up and down it is not adding or subtracting by the same number, so it is not going to be in that slope-intercept form. For this one, notice I would take 1 times 1, it's 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So my equation is going to be a to the n equals n times n, Or another way that I can write that is just n squared. And then again, I want to find the 20th term for the second part. So I am going to plug in 20 in for my n's. So I'll have 20 squared. And 20 squared, I end up getting a total of 400. So my 20th term is going to be 400. Now this next part, it says determine whether the sequence is arithmetic. If so, find the common difference. Now arithmetic means that the sequence has to be adding or subtracting by the same number. So for this first one, notice they're adding 3, but they don't keep adding 3. And it is increasing, so they're not subtracting number. So this one, it is not arithmetic. Now this next one, they are subtracting 5. They're subtracting 5, they're subtracting 5. So we would say, yes, this one is arithmetic, and then the common difference is it's subtracting 5. Now for number 9, it goes ahead and says, find the 24th term of this sequence. So we know it's an arithmetic sequence. They're adding or subtracting by the same number. So I'm going to go to my formula sheet. I'm going to use this first formula on my formula sheet under arithmetic sequence. So let's write that formula down. Alrighty. Now we want to find the 24th term, so that is going to be our n. So I'm going to plug in 24 in for my n's. And then this a to the 24 just means what is the 24th term. I'm trying to solve for that, so that's going to be my missing variable. My a to the 1 is what is my first term. So my first term is 2, so I substitute that in. Then 24 minus 1 is 23, so I can simplify that down. And then my common difference is what am I adding or subtracting by. Notice I'm adding 1.5, so I'm putting a positive 1.5 there. If I was subtracting 1.5, then I would just put times a negative 1.5 there, would be the only difference. So then from here, I'm going to go through and simplify this on my calculator. So 2 plus 23 times 1.5. So I have 36.5 as my final answer. Now for number 10, I want to find the 28th term. So I'm still going to use this same equation. So then I want to find the 28th term. So I'm going to plug in 28 for my n's. And then from there, the a to the 28 is what is the 28th term. I need to solve for that. The a to the 1, what is the first term? So my first term is 34, so I can substitute that in. 28 minus 1 is 27, so I can simplify that. And then times my common difference. Now this one, notice how they are subtracting 8 each time. So since they're subtracting 8 each time, I'm going to put a negative 8 there. I'm not going to subtract 8 in my equation. I'm still multiplying it by that negative 8. So I'm going to put 34 plus 27 times my negative 8. And I get negative 182. And that would, if I keep subtracting 8, that would be my 28th term. Now this next one, number 11, it says find the missing term of this arithmetic sequence. So if I look at my formula sheet, I'm going to be using this second formula, which is x plus y divided by 2. So to find the middle missing number, you can simply go ahead and add the two numbers. So 40 plus 22, and then divide by 2. So 40 plus 22, we get 62 divided by 2, and we get 31. So then that 31, that is going to be my missing middle number. Now what I like to do when I plug it in, I want to see if it is adding or subtracting by the same number. So notice from 22 to 31, they're adding 9. From 31 to 40, they are still adding 9. So it is arithmetic, and that is the missing middle number. So let's do this for number 12. We add the two numbers, so 24 plus negative 10, and then we divide by 2. So 24 plus a negative 10, or 24 minus 10 is 14. Divide by 2 then is 7. So then I want to check to see if that is the actual missing middle number. So from -10 to 7, notice I am adding 17. Then from 7 to 24, I am adding 17. So that is the missing middle number. So we'll circle those. Alrighty, this quiz, please let me know if you have further questions on it.